So now moving on to inheritance patterns from meiosis. Well, in order to understand it better, it's important to understand the basic information. So there's two types of chromosomes. There's autosomal chromosomes and sex-linked chromosomes. Autosomal chromosomes are chromosomes 1 to 22, and sex-linked chromosomes occur on chromosome 23, also known as the X and Y chromosomes.
So you can have various different types with your chromosomes. So like you could be homozygous or heterozygous for your autosomal chromosomes, where homozygous are when you have both dominant or both recessive alleles, and heterozygous is where you have one dominant and one recessive. For sex-linked, it's a little bit different. Females, because they have two X chromosomes, have the same characteristics as like homozygous, heterozygous, as with the autosomal, but males, because they only have one X chromosome, they are considered hemizygous. Now we're going to move from autosomal inheritance to X-linked inheritance, or sex-linked inheritance. First, we're going to talk about sex-linked recessive traits. A classic example is red-green color blindness. So here you can see that you have an affected male and an unaffected female. So it's a little bit different. You can't just use like big A, little a's for your genotypes. You have to use your sex chromosomes. So like a female has two X's and a male has an X and a Y. So, which means like you go X and then you put the letter, as opposed to just having A. And because this female is unaffected, you know she has at least one dominant allele, but because you can see that neither of her children are affected, then she must be homozygous dominant for the trait. And also, all of her daughters must be carriers because they will get one recessive allele from their father. So with sex-linked recessive traits, a classic pattern you see is that males are more affected than females because they only have one X chromosome, which means that if they get one recessive allele, they will show the trait. And also, if you have an affected father, none of his sons will get the trait because the father only gives the Y chromosome to his sons, and if it's an X-linked trait, you won't exhibit that trait unless your mother is affected. And if you have an affected father, all of his daughters will have at least one allele of that recessive trait because the father can only give the recessive allele to his daughters.
So now moving on to X-linked dominant inheritance. Again, just like X-linked recessive, you have the X and Y genes for the male and then the X and X for the female. So again, like autosomal dominant, with just one dominant allele, the gene and phenotype will be expressed. And if you look here in this first example, the male is affected, meaning that he has a dominant allele on the X. And for the unaffected female, the only way you can be unaffected is if you're homozygous recessive. And if you go on to the second generation, you can tell that all the daughters are heterozygous because you're getting the dominant allele from the dad, but then the recessive allele from the mom. But one thing to keep in mind is that whenever you have an affected dad in X-linked dominant, that means that all the daughters must also have the dominant trait being expressed because they get that dominant allele from the father. And that's what it shows us in this example. And here's the Punnett square from the cross of generation 1, and you can see that all the daughters are heterozygous for the trait.